Kim, our fluids project's due, so do you have any idea what we're doing?
No.
Good idea. Viscosity of honey. How's that sound?
Sounds boring. You're boring.
But it's good. Let's go poke holes and stuff. So what we're going to do is, we're going to take this can. Kim's going to poke a hole. And we're going to measure the time it takes for the whole can to drain. Then we're going to get the continuity equation. And we're going to compare the two times and see how close they are. Poke that hole, and remember, I'll be right. I'll tell you when to drain it, okay? Hold on.
Ah! There we go. Ah, I got Coke all over. Ew.
Alright, pop that top, or poke that hole, Kim. Poke that hole.
Ready?
Poke it.
Pour ground.
This is a big middle finger to Mother Earth right here. Okay, so our first try, we screwed up somewhere. Not entirely sure where, but our numbers are off by a lot. So we're going to try a different method. This time, we're going to poke the holes at the bottom and keep the cans at a constant height. And then we're going to compare. That's good.
Cool.
That's perfect. That was a good catch too. Tell me when.
Ready? Hold on, let me open it first. Ready?
Yeah.
Go.
The average time for these cans draining is 17.79 seconds. So now we got our continuity equation. DDT MCV plus the summation of mass out minus the summation of mass in equals 0. Well, we have no mass going in, so that goes to 0. Then we simplify some terms. Then we move this over here. Now, wouldn't you know it, some deltas or some rows cancel out. So now we move stuff over. So now we have big D squared over little d dH dt is equal to minus negative square root 2gh. Set up the integral and move stuff around. Move this over here to get with the h's. Move this stuff over here to be along with some t's. Now you see we have h naught and h final, and over here we have t naught and t final. Well, you see t naught is time 0. We care about this tf, so we gotta solve for tf. So then integrate. Solve for tf, and this is our monstrosity of an equation. There goes the Coke can. hf goes to 0 because we drained the Coke. The final height is not. Now when you plug in these values, most of these values are the same. We're just caring about this d and the other d. What you end up with is around 13 seconds. Well, we got 17.79 seconds, so what went wrong? Well, my assistant Kim here, we're about to learn you some of what went wrong.
Poked the hole in the can. Whenever I poked it, liquid spewed out, and that resulted in a liquid loss. So I had better measurements too, like when I measured it with the ruler. Like the liquid was draining. I mean, I could have, how do you say it, like...
We could have stopped the time a lot sooner. I bet you thought I was done, but nope. You see, a little stroke of redheaded genius whacked me on the head and gave me some insight on something. So let's come over here to my handy dandy little chalkboard. This is our Bernoulli equation. Now, the pressures will go to 0 because we opened the can in 2 spots, atmospheric pressure. The velocity here, at the beginning it's 0, but in the end we're solving for a final velocity coming out, so it's okay to put that to 0. So what we do next is we solve for V2. So V2 is equal to the square root of H2G over this alpha. Now you see, here's what was maybe tripping us up. We were assuming that alpha was equal to 1, but let's pick a new value. Let's just pick 2. So 2 cancels out, and now velocity is the square root of hg. Now let's go back to our continuity equation, and let's see how that plays through. Here's our continuity equation one more time. You already seen me simplify it once, so I'll spare you the details. But maybe I'll speed it up a little bit this time. The t becomes 19 seconds. So maybe the alpha was 2, maybe it's a different number, or maybe me and Kim are just terrible experimenters. You decide.